So good morning everybody, myself Acharya Vishwendra, and let's discuss NCERT line to line, chapter 14, semiconductor electronics. So let's start with the question 222. Due to applied voltage, electrons from N side will move. So certainly they will move toward P side. So first is correct over here. Next is due to applied voltage in forward bias, holes will move from P side to N side or N side to P side. So obviously if we consider the PN junction over here, so suppose this is P, this is N. So in forward biasing, the direction of the electric field due to battery will be like this. So as holes move as apparent positive charge, so certainly there will be force in the direction of electric field. So they will move from P side to N side. So first option is correct. Next is the above process is called. So this process is called minority carrier injection. So this is option number 2, because due to the external electric field, holes moves from P to N, and in N they are in minority. So this is called minority carrier injection. Next is due to minority carrier injection at the junction boundary on each side, minority carrier concentration, obviously it increases. Then we have barrier voltage is shown in figure, battery voltage without battery. So this is shown by 2. Barrier voltage under low external voltage, here it is given that in under forward bias. So naturally this is not gonna be 2, it's gonna be 1. Next is under low external voltage. So if external voltage will be low, then barrier voltage will be reduced to low point. So it will correspond to 0.2. Whereas under high bias, barrier voltage or the height of barrier voltage will further decline more. So it is correctly shown by number 3. Next is forward bias. Forward bias minority carrier injection is shown correctly as. So as we can see that near the junction, in the P-type semiconductor, there is injection of electrons, and near the N side there is injection of holes. So this is correctly represented by 1. Next is in the above question, injected electrons move from junction edge of P side to other end of P side or other end of P side to junction edge. So because of the concentration gradient, here concentration of electrons is low. So electrons will move from this side to the other side. So they move from the junction edge to other side of P. So first is correct. Next is in the above question, injected holes move from. So obviously junction edge to the other side. First is correct. Next is in the above question, the total diode forward current is, obviously it is the sum of Hall diffusion current and the convectional current. Next is in the above question, magnitude of current is, so this is usually in milliampere. So first is correct over here. Next is in the reverse biasing of a PN junction under reverse bias. So P is connected to the negative terminal, second is correct. Next is direction of electric field due to applied voltage and the electric field, so they are parallel to each other, they support each other. Next is effective voltage, it becomes V0 plus V. In reverse bias due to external biasing, so due to external biasing, flow of electrons is suppressed and flow of holes from P to N is suppressed. So both are correct. So suppose this is P, this is N, we have junction field like this, and if we apply, then certainly the electric field due to battery will be like this. So on holes there will be a force like this, and on electrons there will be a force like this. So it will suppress the movement of electrons from N to P and of holes from P to N. So the flow of majority charge carriers is suppressed, which leads to less current. So third is correct over here. Next is in reverse bias diffusion current as compared to forward bias. So obviously it decreases. Next is in reverse biasing due to drift current. Electrons move from P side towards N side and holes move from N side to P side. So both are correct over here, so third will be correct. Next is in reverse biasing. In reverse biasing, drift current is of the order of, so it's of the order of microampere. Next is in reverse biasing, drift current is low because motion of charge carriers is from their minority side to majority side. Obviously, in reverse biasing, drift current is low because obviously motion of charge carriers is from the minority side to the majority side. So first is correct over here. Next is under forward biasing of a PN junction, drift current does not flow. Drift current is negligible as compared to the diffusion current. So second is correct over here. Next is the diode reverse current is dependent on applied voltage or independent of applied voltage. So this is independent of applied voltage. Even a small voltage can sweep out the minority charge carriers. So second is correct. Next is why reverse current in a diode is independent of voltage. So this is because of the first reason is sufficient to sweep the minority carriers. First is correct. Next is the diode reverse current is limited by obviously the concentration of minority carriers. Second is correct over here. Next is current under reverse bias is essentially voltage independent up to obviously breakdown or breakup voltage. So this is the breakdown voltage.